Hi, I'm Scott Campbell with Solve 3D.
And I'm Kevin Miller at Solve 3D.
Kevin, we're looking at this project that you have here, but in the lower left window there where the map should be, it looks like you're in the middle of the ocean. What's going on there?
Yeah, so what's going on here is I haven't currently set a projection. And normally, I mean, this is an outdoor environment. Normally, I probably would know my projection, but let's pretend like I don't know this projection at all. Maybe it's a local system or a local coordinate system. And I just want to tell the system where it is in the world. And to do that, I have to create what is known as a local projection. So if we flip over to our map, we can zoom way out. You see this is somewhere in the middle of the ocean. I'll got to zoom way, way out. And I know for a fact that this is collected somewhere in Denver, somewhere around here. So the first step is to just navigate to where you are. And I know this kind of intersection is somewhere in this intersection here. So navigate the aerial map to someplace where it actually is. And I like to switch to world view to actually see some of the features. So I can even see, I know there's a big traffic light here. I can actually see this traffic light going across the road here in the center of my screen. So now to define the local projection, all we do is go to Tools, Projections, and create local projection. And a local projection aligner loads up. And if you're familiar with our data aligner process, this is almost identical to that, just in a slightly different way. So the first thing you need to do is at least define 3 points in the aerial window and 3 matching points in the point cloud. So it's simply just a matter of clicking the thing in here. So let's we click the aerial control point, and then I'm going to select on this map. I'm going to select, I think this is about the left side of that traffic light here. If I switch back to my point cloud view, I'm at the north side. Zoom out, I'm at the north side of this. So that's this guy over here. I'm going to select that pole here. And then again, back to the aerial view. I'll select another one, go to this one. And on my point cloud, I can even do it in this little window if I want. Select this other side. And let's select a third point. Maybe maybe there's the kind of the bottom of this intersection down here, which is way across here, about here. So I select the 3 points, and then I can add more if I want, but 3 points is the minimum. I just simply click Calculate Transform, and you see now my aerial map has jumped and it's now moved all of my camera locations to, based off those 3 points I selected, it's now moved them down to hopefully where they should be. And they look pretty good. They're following the road there. You can see each lane of traffic, and it's looking good. So now if I'm happy with that error, I mean, there is some, I mean, you could get really close to, if you were doing this for real, you might want to really focus on what you're clicking on. Hopefully you can see it. But yeah, you want to get this error down as minimally as possible. And then you can just click Save Local Projection, give it a friendly name. So we can call this, I don't know, intersection, and hit submit. And now it's saved. So now we got our spot.
Right on. Looks pretty useful, Kevin. And looks pretty easy to do, too.
Yeah, it's really simple. All right.
Okay, now let's talk about colorizing LiDAR from imagery.
Right. So there's a number of ways of doing that. We currently support 2 different ways. One being colorizing from the, say in this case, panoramic photos that were taken. So we have, we have our intersection here, and if I turn down my point cloud, you can see the panoramic photos. So that's one way, is using these types of photos to colorize. And the second way is to colorize from some aerial imagery, which I'll show you in a little bit. So let's start focusing on the panoramic imagery. So to do that, I'm going to switch just to show you here. We have, I'm switching my point cloud to color settings. And if I turn it up, you can see right now my point cloud has been, I don't know, colorized at what looks like maybe intensity values. So if we want to use the panoramics instead, what we need to do is open the workflow viewer part of Engine. And we're going to search for color panoramic, add that. And then we simply just need to select the point cloud that we want to colorize. So if I go back here to my color intersection, I select intersection. And then I need to select a CSV for my images. So here's my intersection CSV. And then I need to actually specify the folder where those images are. So I'm going to select the images folder. And then I need to enter a couple parameters. So I need to enter how far away to color. So if you think about as you're driving down the road, there's an image for each location where there's an image captured at, say, every 10 meters down the road. I want to colorize a certain distance away from that position of that image. This is helpful if you have a really large area. You don't need to spend time trying to colorize something like a mile away. So I want to say maybe let's go with 100 feet in this case. So this is imperial or survey feet collection. And then there's some advanced parameters for doing things like, I'll talk about the image mask in a second, but weighting by distance, figuring out overlapping points. I like to leave those on the default at start, and our whole user guide goes into some more details about this. But yeah, so we're just going to do this basic colorization. So then we have to select an output file. So I'll call this intersection and hit execute. So again, we just got to wait for the logs to go by. It's going to do some math here. And this will take a few minutes depending on the number of photos you have. In my case, I only have 36 photos here for this intersection. So it'll be pretty quick. But if you had 100 miles of interstate or something, this could take a few hours to run at least. So we'll just let it run here. Okay, Scott, we are finally finished here, and let's just take a look at some of the results. So I should mention that this really you have to make sure your data is aligned with your point cloud. So if it's not, you won't be able to use this feature. So make sure your imagery is aligned with your point cloud. But what we're going to do here is look at that intersection demo file. I'll just load it in beside this one. And if I turn off my old one, you can see now it's colorized. So if I zoom out, you can see vegetation and the road and those sidewalks and everything are nicely colorized in the paint markings. One thing you may mention, though, you may notice is this yellow MX50 device, in this case, is very visible. Where is it here? This part is very visible in the colorization of the image or of the point cloud, as you can see here. So if you don't want this to happen, there's actually a feature for this in the advanced parameters called image mask. So this allows you to select a JPEG. Let me open this JPEG and I'll show you what it looks like. So what I did in this case is I opened one of the panoramics and I basically colorized over the yellow part in the image. You can kind of see that same kind of sensor part. I colorized everything that I did not want it to use for the colorization process. I made that black, and then everything else I left white. So when I do that mask, I'll just show you some of the results here. If I load one of these tiles again, here, this one. There we go. So you can see it's now gone. So it's ignored all that part in that lower half of the panoramic. So yeah, so that's essentially the color from Pano.
Right on. Looks pretty good. All right, let's talk about how we would convert going the other way. How can we convert a LAS file into an orthomosaic?
Right. So there's a couple ways of doing that, but the what we've started to do as an initiative in the engine is to, inside of the viewer, actually call some of the workflow functions. So you could go back into the workflow view and do there's a function called las to orthomosaic, and you can simply add it here and select your channels. But the more fancier way, if you want to get into the viewer, is to simply just right click on the file you want to use for an orthomosaic. So I'll use this nice colorized point cloud that I have. I can right click on it, and there's a new execute function menu under here. And we'll slowly be adding more and more functions to this list. But we have the last orthomosaic function. So we select that. And same parameters as the workflow view, but you need to select at least one channel to fill in your image. And if you think of an image, typically an image has three channels, a red, green, and blue channel. So if I wanted just a nice colorized orthomosaic, I can select red, green, blue for these channels. Otherwise, if I want, maybe I want to use a normals calculation or the linearity values or the number of returns or the classification number. Again, it's up to me how I want to generate my image. If you are going to use some of these values, your image isn't going to look super nice and colorful, but it'll have maybe some characteristics in it where maybe possibly if you're using our deep learning toolkit to identify certain object types in aerial imagery, it might actually pick up very well, say for shoreline detection or water edge detection or curb edges, things like that might actually do a really good job depending on what kind of attribute you pick. So just for something nice to look at, we'll just stick with the red, green, blue. And then you also have this pixel size. This is how dense to make the image. So every pixel or every unit is going to create a pixel in your image. So if you have this set to 1, that means 1 meter essentially is what it is. So every meter of space is going to have 1 pixel in your image. So you may want to reduce this depending on what kind of detail you want. So we'll just leave that at 1. And I'm going to select an output folder. I have an ortho folder already. And I'm going to hit submit. So if you're running this from the viewer UI, you still get all these logs. We're working on some more fancier ways of showing this, but this is how it shows up now. And it's now going to cycle through this point cloud data. It's pretty quick at 1 meter. So I'll just let this finish. There we go. And it's going to import that results right away. And here we go. We have our, it's pretty blurry because of, what I said, 1 meter of
1 meter, yeah.
is thing. So you can kind of get the idea of, let me just back up here of where it is. So I don't have my projection set, so it's in a weird place, but yeah, it's essentially what it is. So you have that TIFF file. It's a georeference TIFF, and yeah, that's how it works.
Okay, thanks a lot, Kevin.
Yeah, no problem.